The next part is the principle of argument. Next concept we need to understand is principle of argument. So coming to the principle of argument, again I'll consider a characteristic equation. Consider a characteristic equation. D of s is equal to 1 plus g of s into h of s. This is the characteristic equation. This is equal to k into s minus a1, s minus a2, so on, till divided by s minus b1, s minus b2, so on. Okay, now this is d of s. Now here uh, a1, a2 are the zeros of characteristic equation. This is important. They are the zeros of the characteristic equation. B1, B2, so on are the poles of the characteristic equation. Now, S is a complex variable. X is some complex variable which will have a real part and an imaginary part. Sigma plus j omega. So, with this d of s will also be a complex variable with u plus jv, that is real and imaginary part. Now, first rule is uh, based on the counter. So the first one. So if I take the S plane here, this is the S plane, and this is the D of S plane. So coming to the first rule here. Now, if you take any counter, if you take any closed counter in the S plane, such that the closed counter will not enclose any zeros or poles. Like I've taken a closed counter here. This is a closed counter in the S plane. Now within this, inside this closed counter, there are no zeros and no poles present. So all your zeros and poles, that is A1, A2, B1, B2, are placed outside this closed counter. So within this, you don't have any zeros, you don't have any poles, and that I'll take the direction to be in clockwise direction. The counter direction is in clockwise direction. Now, when you map all the points, these points, now on the closed counter, you have points. Okay. See, if all these points are mapped to D of S plane, then you will have a similar you will have again a closed counter will be there. Now this closed counter will also be in the clockwise direction. Even this will be in the clockwise direction, but it will not encircle the origin. So if you take any closed counter with encircles neither zeros or pole, then the counter in the D of S plane cannot encircle the origin or the point at the infinity. So I can write it as, so this I'll take it as counter C. This is counter D. Fine. So if the counter C encircles neither zero nor pole, then the counter D, that is this counter in the D of S plane, cannot encircle the origin. That is the first point. So here in the inside region of the counter C, it is not having any pole or zero. So if the same, if we trace the counter C in the clockwise direction, then the inside region will be on the right side of the counter. So if you take any point here, uh, so I'll take some point here, and there is one more point S1. So the S1 will be placed, if you consider from, if you look from this side, so S1 will always be at the right side of the point on the counter. Okay, now similarly, if we take next counter, I'll take next example. So here, now the counter in the S plane is enclosing two zeros. This is the counter C, and there are two zeros placed. So one zero is placed here, one more zero is placed here. And this counter is traced in the clockwise direction again. So the counter is traced in the clockwise direction. Now, when we map it to D of S plane, when this is mapped to D of S plane, then the counter in the D of S plane will the counter in the D of S plane will encircle the origin twice in the clockwise direction. So in the clockwise direction, you can see it is encircling the origin twice. So based on the number of poles inside, based on the number of zeros inside the closed counter, the counter in the D of S plane. So this is D of S plane, and this is S of plane. So the counter in the D of S plane will encircle the zero twice. So if you have three, if inside this, if you have three zeros, if you have one more zero, then it will you will have one more encirclement to the origin. So this is your rule number 2. So which I'll write it as, okay, if the counter, if the closed counter C encircles Z number of zeros in the clockwise direction, in the clockwise direction, then the counter, so this is C counter and this is D counter, then the counter D in D of S plane encircles the origin, encircles the origin Z times, Z times in clockwise direction. So it is like if you take Z zeros in the clockwise direction in the S plane, so that many number of encirclement will occur in the D of S plane in the same direction as that of the original. So here in the S plane, if you have it in clockwise direction, there are two zeros within the clockwise direction. Then in the D of S plane, you will have two encirclements around the origin in clockwise direction. If in the S plane you will have three zeros in the anti-clockwise direction, then in the D of S plane you will have three encirclements around the origin in the anti-clockwise direction. So the encirclement for the encirclement of origin will be in the same direction as that of the encirclement of the zeros in the S plane. So I can write the encirclement of origin in D of S plane will be in the same direction, in the same direction as that of encirclement corresponding, so as that of corresponding encirclement of zeros in S plane. So if you take a S plane, a closed counter where four zeros are taken and they are encircled, the counter encircles the four zeros in the anti-clockwise direction. Then if you map that counter to the D of S plane, you will have four encirclement of the origin in the anti-clockwise direction. This is your rule number 2. Second one is when there are only poles present. So that we will see it in the next video, when the poles are present and when both poles and zeros are present in the encirclement. Thank you.